So when you're changing the fraction here, think about how you can change it to decimal. The easiest way is if your denominators are part of a 10, it's easy. Okay, so let's consider that. And let's see the first one. And I will ask your opinion, your idea about the rest of these. Okay, so the first problem is 7 over 2 to the 6th power. What is
the screen?
Oh, thank you. I always do the line. How about now? Better? Okay. All right, so tell me what I can do. This is 2 to the 6th power. It's not power of 10, it's power of 2, right? So how can I change this to power of 10? So if you think about 10, 10 is what times what? 2 times 5. You can use the prime factorization, right? So if you have 2 times 5 as 10, 10 squared is 2 times 5 times 2 squared, right? Or you can distribute the exponent and have 2 squared times 5 squared, right? And for 1000, this is 100. And think about 1000, that's 10 cubed, which is 2 times 5 to the cube, which is 2 cubed times 5 cubed. So if you have the denominator as 2 times 5 to the something power, you can easily change that to power of 10, right? So here I have 2 to the 6th power. If I multiply this by 5 to the 6th power, the denominator will be 10 to the 6th power. Do you agree? Yeah, but this is not equal yet because I multiplied 5 to the 6th power only to the denominator. So I need to do the same thing to the numerator. Then it's still equal, right? So because I multiplied 5 over 6, 5 to the 6th power over 5 to the 6th power, which is 1, I can multiply a number by 1 and get itself. So these are now equivalent. What's the denominator? What's the numerator? 7 times 5 to the 6th power, right? Now you can see that this is, what is it, 1 million, right? And what's 7 times 5 to the 6th power? You can ask your calculator to do the job. Did anybody calculate this? 5 to the 6th power times 7? 5 to the 6th power is 15,625. If you multiply that by 7, you get 109,375 over 1,000,000. 3, 4, 5, 6. Now we know how many decimal points we need to move. So here we know that 5 here is the ones place, right? So if there is only 1 here, it's gonna be exactly the same. So you have million, which means you're moving the decimal points to the left, right? Because we are making the number smaller. When we are dividing by big number, the number goes smaller, right? So if you are dividing, you need to move the decimal point to the left. Since we have 6 zeros, you can move that to 6 digits. 3, 4, 5, 6. And that's where the decimal point goes. 0.109375. What do you think? Good? Okay, let's look at the next one. You have the 1 over 2 cubed times 5 to the 4th power. Any idea? Can we change this to 2 cubed? And I know I need a 5 cubed here to make 10 cubed, right? But since I have 5 to the 4th power, I just need to multiply this by 5 to the 1 power. Then these together, 5 cubed times 5 to the 1st power will be 5 to the 4th power. It's exactly the same. You see that? You see that? Yeah, so these will be 10 to the cube. So if I rewrite that, I have 10 cube times 5. Right? This is 10 cube and this is 5. Right? So what do I need? What do I need to make this to power of 10? What do I need? 2. Yeah. Come on, guys. Make a louder voice. I know you know this. So tell me with a louder voice, I can hear you. I didn't bring my hearing aids today. So I need your loud voice. Okay, so what do I have here in the denominator? Yeah, 10 cubed times 10. How about in the numerator? 2. 2. Now, what do I have in the denominator? 10 to the 4th power, right? I have 3 and I have 1 more. So that makes 10 to the 4th power. So if I rewrite that, I have 1, 2, 3, 4 zeros there, right? Since you're dividing 2 by 10,000, your number will be smaller. So we can move the decimal point to make it smaller to the left. 1, 2, 3, 4 places, right? What do I do with these? I need to indicate them. There's nothing. The decimal point is here. So I need to put the zeros as placeholder. So I get 0.0002. Does it sound good? Okay. So how did you do the C part? Can I erase this? Okay. So let's look at C. 1 over 125. So the easiest way is, just like the other two problems, if we have prime factorization, it obviously tells us what we need to multiply more to make 10 power of 10, right? So let's do the prime factorization. 125. Oh, we can see that it ends with 5, so it is divisible by 5. So let's divide it by 5. What do we get? 5 times 25 makes 125. So we have 5, and 25 is again divisible by 5. So 5 times 5, right? So we are done. This is 5 cubed. You can just rewrite this as 5 cubed. So it's the same number. Now we can see what we need to multiply here, right? What do I need to multiply? 2 cubed. Do the same thing. 2 cubed. Then we can easily solve this. So we have 2 cubed or 8, and we have 10 cubed there, right? So 8 over 10 cubed is 1,000, which is, you can do the same thing. Decimal point was here. 2 divided by 1,000, your number will be smaller by 3 places. 1, 2, 3. So decimal point will be here. So what do we do with these 2 places? We put zeros there. It's gonna be 0.008. Is it? Yeah. Well, let's do the last one. 250. 7 over 250. Okay, again 250. We can do the prime factorization. 250 is divisible by what? 10 or 5. So let's think about 10, because it's easier number. So 10 times 25. They are not prime numbers yet. So 10 is what times what? 5 and 2. How about 25? 5 and 5. So we are done, right? We only have 2's and 5's. So we see 250 is 2 times 5, what? Cubed, and 7, right? So we can combine these 1, 2, and 1 of that 5 from 5 cube. So we can have 2 times 5. Then how many 5s are left? 5 squared is left, right? So that makes 5 cube, 1 5 and 2 5s. So that makes 5 cube. It's exactly the same. Now we have 10 times 5 squared, and 7 is in the numerator. So as you can see, we already have 10 here. We just need to change this to power of 10 by multiplying this by 2 squared, right? We'll do the same thing. Then we know that this will make 10 squared. So we have 7 times 2 squared, 4 over 10 times 10 squared. This will be 10 squared, right? So we already have 10 and we have another 10 squared. So what is the denominator now? 10. Louder. Cube. Thank you. And the numerator, 7 times 4, 28. We have 28 over 1,000. So you can think about changing the decimal point again, because you're dividing by 1,000, your number will be smaller. So you need to move the decimal point to the left by 3 places. What we do here, we're gonna put zeros there, right? So we have 0.028 as the answer. Very good? Okay. My question for you is now, what do you notice so far? Our denominators were all about 2 to the some power and 5 to the some power, wasn't it? And our decimal was terminating, or it was going on and on and on. It was terminating. So can we conclude that if it is a terminating decimal, the fraction form was always like 2 to the some power times 5 to the some power is the denominator? Yes. So if you see any fraction with 2 to the some power times 5 to the some power, it can be 0. You know, so the power should be power that, let's put that as our A and B, where A and B both are greater than or equal to 0, right? If B is 0, for example, 2 to the 6th power times 5 to the 0 power. 5 to the 0 power is what? 5 to the 0 power is what? 1. This is what? 7 over 2 to the 6th power, isn't it? That's exactly the same as our first example, 7 over 2 to the 6th power. It was still terminating decimal. Okay, so your power here, exponent, can be 0 or greater than 0. Okay? Then you can change this number to a terminating decimal. What if we have some other prime numbers in the denominator? So for example, if we have 2 to the 5th power times 3, something like that. And let's put some number here, like 7. You think this will be a terminating decimal or not? You can use your calculator to calculate this. Okay, so 7 over 2 to the 5th, 2 to the, I'm using my calculator now. 2 to the 5th is 32 times 3 is 96. So 7 divided by 96 is 0.072916666. It goes on and on and on and on. So it's not terminating decimal, right? So you can think about any denominator that is other than 2 or 5 is a prime factors, then it is not the terminating decimal. To make the terminating decimal, you need to change that to something over 10 or over 100, over 1,000, over 10,000, and so on and so on. It makes sense because take a look at any terminating decimal. Just make it up. It's terminating. We can always read it as power of 10. So this is what? 20,578. 1, 2, 3, 4, 5. Right? 100,000. We can always write any terminating decimal into power of 10 as the denominator. Right? That's why we need to have 2 or 5 in the denominator. If we have any other number, it's not going to be terminating decimal. Okay? Okay, let me challenge you a little bit more then. What if I have this number and this number, and 12 is the numerator? Do you think this is terminating decimal or not? What do you think? At first glance, you can see that, oh, I have 2, 5, but I have 3, so it may not be the terminating decimal, right? But think about that again. This is not simplified form. It's not simplest form, right? Because 12 can be divisible by 3. You see that? So it's actually, and 4 is 2 squared, so this will be cancelled with 2 of them, leaving only 1 there. It's actually 1 over 2 times 5 squared. Now this is the simplest form, and we don't see any 3's there. We only see 2 or 5 in the denominator. You see that? So yes, this is actually terminating decimal. Okay, so what you need to do is, you need to think about what's the denominator. Is that power of 2 or 5? When it is the simplest form. Okay, so make the simplest form and then see the denominator, whether it is 2 or 5 as the factors. Make sense? Okay? Okay, I will give you one more example. Do you think this is terminating decimal or not? And justify that for me. Anybody?
Yes.
Yes, terminating?
Yes.
Ooh, all of you said that. Okay, justify that for me. Why?
30 is divisible by 6.
30 is divisible by 6, so let's divide it by 6, and we get 1, and we get 5 here. So this will be cancelled with 1 of them, leaving only 1. We have 2 to the 5th times 5 as the denominator. Yes, the denominator has only 2 or 5 as the factor, right? So it is terminating. Great job, guys. All right. I think we got the idea, right? Let me go back to our screen here. Okay. Can you think about this then? Which of the following fractions can be written as terminating decimal? 7, 8, 11, 750, 21 over 7, 37 over 7, 62. I will give you about 2 minutes, maybe less than 2. to solve this one, you need to have a skill for prime factorization. You guys know that reading assignment 3 was due today, right? We have only about 3 weeks left, right? My plan is to finish all the way to section 7.5, which is real number. So maybe we will speed up a little bit, but not intensively, because I have beliefs that we need to have understanding of math, not just covering, the curriculum. Yeah, the plan can be changed, okay? I will keep you updated about that. All right, how do you feel about these problems? Good? Okay, so help me out. Do you think this is terminating decimal or not? Yes? Yeah, I see a lot of nodding. Please say yes or no, okay? Okay, why? Because the denominator is 2 to the third power, right? 2 cubed. And nothing can be cancelled. So this is simplest form. Yes, it is 2, so 5 to the 0 power, right? It's form of 2 or 5 as the denominator. How about 11 over 250? Yes or no? Yes for terminating decimal. Yes or no?
Yes.
Yes?
Yes.
Yes. Okay, show me why. How did you factor 250? We did this before, right? 10 and 25?
Mhm.
So we have 2 times 5 cubed. Can anything be cancelled?
Nope.
So yeah, only 2 or 5. How about this one, 28? Factor that, 28, 2 times 14. 14 is 2 times 7. So we have 21, 2 squared, 97. We see 7 there, so is that not terminating decimal? It is, why? Yeah, because 7 divides 21 as well, right? Okay, so actually that is 3 over 2 squared. So yes, it is terminating decimal. Good job. How about the last one? 768. No, it's not. Let's see. 768 is divisible by 2, obviously, because it's even number. 2, 3, 8. Okay, and this is also divisible by 2. So I see 19, 2. Again, 2, half of that, 81. And it's 9 times 9, which is 3 times 3 times 3 times 3, right? So I have 37 over 2 to the what power? Third, and 3 to the fourth power. Is 37 prime number or not? It is a prime number, so it doesn't have any factor of 2 or 3. So it is simply the fourth, right? So as you can see, we have 3 to the fourth power. So it is or it is not terminating decimal.
No.
Very good. So it's no, it's not. Great job, guys. So I believe you have the idea about finding 3 in decimal. Can I take it back? Yeah? Thank you. Okay, why is that going? Okay. Okay, we already know that fraction can be, to find the decimal, you can do the division here, right? So the numerator becomes the dividend and the denominator becomes the divisor, right? So we do 1 divided by 3, not 3 divided by 1. So let's do that one together. So 1/3, we know that it's gonna be 0.00, I mean 0.33333333. You already know that. So let's just verify that. So it is 1 divided by 3. Some students, actually a lot of students make mistake doing this by doing that, 3 divided by 1. A lot of students have misconception about the dividend has to be bigger than the divisor, right? So please make sure you divide this number by the denominator, okay? So numerator becomes a dividend, and denominator becomes the divisor. Okay? Please make sure. Now you can easily think about this is the correct one. So 1 divided by 3. So when you are doing the long division, we don't have enough. 3 doesn't go in 1, so we can think about the decimal point there. And then pretend it is like 10, not 1.0. And you're going to think about how many 3 goes in 10. 3 times 3 is 9, that's closest. If you have 4, it's more than 10. So what is left? You can subtract it, right? So you have 1. And you can drop down 0 again, because there are, infinitely many zeros there. So you can keep dropping that to see whether you can divide that by number by 3 or not. So you can continue that, and as you can see, there's a pattern, right? So 10 minus 9 is 1 again. You can drop down another 0 there and have another 3 there. So even, without going further, we get to know that, oh, it's going to be 0.33333333, right? So that's 0.333333 there. It is not terminating decimal. And we can verify that saying, yeah, the denominator is not 2 or 5. Yeah, so we can use the repeating bar there. We're going to talk about that later too. But just remember that you're going to divide numerator by denominator. Okay, and you're not going to have any problems with that. Okay, so let's think about the ordering terminating decimal. If you are comparing 42.875 and 423.95, which one's greater? Which one's greater? 423.95, right? How do we know?
Because the whole number.
Exactly. Exactly. Where did my table? So we have 42.875 and 423.95. Hey, was the Haley? Okay. Haley has said she looked at the whole number, 42 and 423. I think that's a really good idea, right? You don't even have to look at the decimal parts there, because we are seeing that, oh, there are 42 wholes, right? And 423 wholes. I'm talking about whole, right? And obviously, this is so much bigger than 42. So you don't even have to look at the decimal part. right? So yeah, it's a great idea to compare the whole numbers. Common mistake that students have is like 92 point, let's see, 30 and 109.457. Two common mistakes. They ignore, first one, they ignore the decimal point, right? And look at the first number, 9. Oh, that's greater than the other one. Okay, some people make that mistake. Another mistake that we have observed is, oh, which one's longer? Sometimes they see the longer number, no matter where the decimal point is. If it's longer number, like this, it is bigger number. So you need to pay attention what that decimal means. It shows where the whole numbers are. So they can compare 92 with 109, and this is greater number, right? Okay. So knowing that, we can continue with some examples. Okay. Can you compare these two numbers? 53, let's see, 53 and 53, 53.47 and 53.81. So 53.47 and 53.81. Okay, let's compare the whole numbers. They are the same. Then what do we do next? Exactly. You can look at the next number right after the decimal point, because that's the next number that is in the greater digit. So between 4 and 8, this is 4/10, that's 8/10, which is bigger. This is bigger. What if they are the same? 4, 7, and 53.41. So you look at the whole number, they are the same. Then look at the next digit, they are the same too. Then you can look at the next digit, right? Compare those two, which is bigger, 7 is bigger. So you can say this number is greater, right? That's pretty clear concept. Okay. How about these two? Which one is greater? 39, that's greater. Okay. How about, yeah. So one technique that you can do with your students, I don't have the notebook, but when you're looking at your notebook, it's a horizontal lines, right? You can flip it over, then you're gonna have vertical lines. I think that's very, very helpful. So what I did with my students, I flipped it over, then you can have vertical lines. You can put the decimal point there and compare all the numbers. So for example, 12.45 and 12.457, you have the same decimal point there. So fill that out, 12.45, 12.457. You can compare that, by the lines. So we can compare 12, 1 and 1 are the same, 2 and 2 are the same, 4 and 4 are the same, 5 and 5 are the same. Then you can look at the next digit. Oh, 7 is greater than 0, and so on and so on. You can compare any number there. So what I'm saying here is, we have this. I can make the lines this way. So let's suppose these are really good lines. So your notebook is flipped sideways, right? And then you can put a decimal point, to compare any numbers. So if you are saying this is your decimal point, all the decimal points will be here that you are comparing, right? So you can compare 12.507, 300, 507, any numbers like 20, 12.507. I can do 12.607. 12.557. 12.570. If you have an example like this, we get to know that, oh, this is obviously the biggest, right? The students can have, this is the largest. And then what? We can compare the next line, next vertical column. We see that this is next biggest, right? So this will be the next number. We can put first number, second number, and so on and so on. Now let's look at the next column. Oh, they are all the same. So move on to the next column. Oh, I see. 6 is the greatest, right? And then the leftover. So that will be the next number. And then you can move on to the next one. And I see that 0, 0, 5, 7. So this will be next number, right? And then this will be next. And then this will be next. Things like that. So that's very, very helpful, okay, to think about that. Okay, I think we are actually done with this one. Let's move on to 7.2, operating on decimals. So operation, we're gonna do the addition and subtraction and multiplication and division, okay? Addition is so much easier when you are doing the same technique. Flip over your notebook and line up with the decimal point. For example, 2.16 plus 1.73. If you are using your line notes in that way, it's so much easier because we can see what digits in which place, right? Okay, so if we are adding them, just make sure you have same digit underneath same digit. Then it gets so much easier. So, and pretend there is no decimal point. Just add as we do normally. Just start from the last digit here. This is for this case is 100th place. So 6 plus 3 is 900. 1 plus 7 is 8/10. And with decimal point here, and 1 and 2 together is 3. So it's gonna be 3 and 8900, right? That's the easiest. If you wanna use the fraction to solve this problem, you can do that too. And we know that in fraction this will be 2n 1600, right? So 2n 1600 plus 1n 73,100. We can add by the whole numbers. We can separate 2 and 16,100, right? I'm not gonna go over all of this again because we talked about that before. And we can use the commutative property here, right? So we can add the wholes together, 2 and 1, and we can add the 16 and 100 together. So we get 3n 89,100. So we know that 3n 89,100 is what? 0.89, which is 3.89. You can connect decimal with fractions as well. Changing 2 and 1600, you can write it this way, or you can also write it 21600 and 173,100 as well, right? So you can just add these two together here. That's same denominator, so we can just add 216 and 173. So I have 389,100, which is 3.89. You can do that either way. Okay, mixed number, you can use that as mixed number, or you can use that as what do you call this? fraction with numerator bigger than denominator, what do you call that? Improper fraction. So you can use that rule. Okay? All right. So addition is so simple. Oh, if you want to use manipulatives like this, again, you can have 100 as one whole, or you can have 10 as one whole. It depends. Okay, so you need to make sure what is your one whole. If you are saying the flat is my one whole, the rod will be 1/10, right? So if you are doing using the same manipulatives as I did here, you can represent 2.1600, 2 and 1600, that's 2 flats, and 1 1/10, and 6 100, and add 1 flat, 7 10, and 300, and then add them together. So visually, your students can see that, right? And then they can have some connection with the answer. Okay, so I have talked about all that. So subtraction, same thing. You can line up the digits, okay, with the decimal points, then it's gonna be easy. How about if you are doing the multiplication? If you are doing the multiplication, think back the fraction multiplication we did. For example, something like 2/3 times 5/7. How did we represent this multiplication? With a rectangle. Remember we did? This rectangle can be broken into how many pieces? 3 pieces. So I can cut that in 3 equal pieces. And only how much is shaded? 2. This shows 2/3. This shows 2/3 of a rectangle. I can also show 5/7 here too, right? By making the same thing now vertically. How many pieces do I need? 7. 1, 2, 3, 4, 5. A little bit bigger. 1, 2, 3, 4, 5, 6, 7. Oh, sorry. Anyways, it's 7 equal pieces, and we have only 5 shaded. 1, 2, 3, 4, 5. 5 parts are shaded. So this will show you 5/7, right? Now, when you are multiplying 2/3 by 5/7, what we look at? We are looking at the overlapping parts, right? So we are looking at the parts that are shaded in here. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is the same as 2 times 5, right? Out of how many equal parts? 21 equal parts, because there are 7 equal parts and here are 3 equal parts. So total 21 equal parts, right? Think about that. And you can do the same thing for the denominator. If you are doing 0.5 times 0.3, you can also show 10 by 10. 10 by 10, because this is 5/10 and that's 3/10. And you repeat, you get the overlapping parts. Right? Okay, so let's wrap up here and we will continue the multiplication when we come back. So homework for 7.1 will be due Wednesday, and I will also open the quiz that includes 7.1, but that's not gonna be due until next time. Alright, have a great Monday. Stay warm. I will see you guys on Wednesday.